So this is a project that is funded by DairyCo as part of the DairyCo partnership, a research partnership that we have. And it's a study that's actually addressing the issue of protein levels in dairy cow diets. And the reason why we're interested in the level of protein that dairy cows are being fed is because we know that over the last 5 or 6 years, protein prices have gone through the roof globally. Protein prices are traditionally dictated by the price of soya. Soya prices over the last 5 years have increased almost fourfold. Peaked late last year in 2012. Prices have come down slightly in 2013, but they remain high and they're going to continue to be high. We are now living in an era of high protein prices, driven mostly by increased activity in Southeast Asia. So this is obviously having a major implication in terms of the cost of feeding dairy cows. And the question that we're trying to address is how can we actually address this problem? One option, of course, is to try and feed cheaper sources of protein. But of course, as soya prices go up, all protein prices go up. The only opportunity to feed cheaper protein is to make better use of homegrown protein. But that doesn't really address the other issue. And the other issue is that the nitrogen or protein that we feed to dairy cows is used very inefficiently. Only about 2/3 to 3/4 of the nitrogen that are fed to dairy cows about 2/3 to 3/4 of the nitrogen that are fed to dairy cows are excreted. Only about 1/4 to 1/3 are actually retained by the animals. And of course, all the nitrogen that's excreted ends up in the slurry lagoon and has to be disposed. And so if we can feed lower levels of protein, it's the main factor that drives the amount of protein or nitrogen that is excreted, then this will increase the efficiency of utilization, and it also has the potential to have some savings in terms of the cost of feeding dairy cows. So we know from extensive experience that we can drop the levels of protein marginally in the diet, and we can tweak the formulations so that we can reformulate the diet in a way that mitigates any loss in yield. But the savings to be gained there are very marginal. And we wanted to push the boat out slightly and ask the question, can we drop protein levels even further? And so we were thinking here about dropping protein from about 18% crude protein down to about 14% crude protein. We know from past experience that if you go below 14%, that the effects are catastrophic. You get a loss of production in yield, which you can't recover from. So it seems to be a kind of like the sort of cliff edge, as it were, in terms of the limit to where we could go. And so in this particular study, which I'm going to describe in more detail in just a moment, we're looking at trying to reduce protein levels from 18% down to 14% crude protein. We know that this can have a benefit in terms of reduced feed costs. We estimate that it could be anything between 130 to 175 pounds during the course of a typical lactation. That works out to be a saving of about 8 to 12%. And we can also significantly reduce the amount of nitrogen that's excreted by the animals by about 10 to 15%. And again, this is based on past experience. The problem, however, is that we'd also expect to take a hit in yield. And that hit in yield can vary from between 450 to perhaps 750 kilograms during the course of a lactation. And so that this can amount to a loss of income of anything up to £200, and this would completely erode or eliminate any savings that might be gained by producing a cheaper feed. And so the question that we are trying to ask is, can we mitigate this loss in production by modifying the diet of the animal? So the question we're trying to ask is, can we mitigate the loss in yield by altering the composition of the diet? And we know from past experience that if we drop the levels of protein down to about 14% crude protein in the diet, that we will have a hit in terms of dry matter intake. And dry matter intakes might be reduced by about 1 kilogram per day, maybe slightly more than 1 kilogram per day, which would work out to be about 11 or 12 megajoules of metabolizable energy on a daily basis. So one of the things that we want to do is to adjust the level of forage and concentrating the ratio to put it a little bit more concentrate in that diet. And this will have the benefit of boosting the amount of metabolizable energy that's been fed to the cow to try and offset any reduction in yield. If we alter the composition of the concentrate that's been fed to the dairy cow as well, that might, if we get it right, improve the nitrogen capture within the rumen. And this is one of the key aspects of the study, is to try and increase the capture of nitrogen in that rumen. It gets incorporated into the microbes. It's known as microbial protein. and it has a high biological value in terms of, if you look at the composition of amino acids within that microbial protein fraction, it more closely approximates that of body tissues and milk, and is consequently very digestible and used with a higher degree of efficiency by the dairy cow. So we're feeding less, but we're hopefully going to try and improve the efficiency with which it's utilised. Now, we might expect that there are some rate-limiting amino acids such as methionine and lysine, which might become important when you start feeding low-protein diets. Other amino acids such as histidine and leucine are also worthy of consideration, but it really goes beyond the immediate scope of this study to look at this at the moment. This is something that we might come back and look at in a little bit more detail in the future. And so we've set up a large production study. This study involves 90 contemporary high-yielding Holstein dairy cows. The study is being located simultaneously at 2 sites, here at Harper Adams, but we also have a group of cows over at the University Farm at Nottingham University. And the 2 systems that we have are quite different. At Nottingham, we've got about 240 milking cows. They're kept indoors all year round, and they go through 4 Lely Astronaut robots. These cows are milked typically about 3 or 4 times a day, and they're producing about 11,500 litres of milk annually. The cows, in contrast, here at Harper Adams are going through traditional rotary parlours. There's about 400 cows in the herd, and they're milked about twice a day, and they're producing about 9,500 litres. And so we have 2 very different production systems, but we're looking at this study in both sites and asking the question, is it reproducible with these 2 contrasting systems? So we've got 3 treatments in this study. We've got a group of control cows which are being fed a more standard diet, which is about 18% crude protein. It's got about 3 parts maize to 1 part grass silage in that diet, and the cows are getting roughly 50% of the dry matter intake is forage, and 50% of the dry matter intake is concentrates. And then if you go to the low protein diet, it's fed a standard energy. It's similar to the control diet in every respect, except we've reduced the amount of protein in the diet. And so again, similar proportion of concentrates and forage in that diet. And then in the high energy diet, we've adjusted the level of concentrates, so it's about 55% concentrates, 45% forage. And we've also altered the composition of the concentrates, put a little bit more starch in there. We've also put a little bit more digestible fibre in the form of sugar beet pulp, which to improve the buffering capacity of the rumen. But essentially all other components of the diet remain the same. Now, it's early days yet. The study began in April 2013. There are 14 cows out of the original 45 cows are still on study here at Harper Adams. We still have 40 cows on study at Nottingham. This experiment is due to conclude in November, at the end of which we'll have all the data. Early indications are that on the standard energy low protein diet, intake is depressed slightly, as we might expect. Milk yield is depressed slightly, as we would expect. But the early indications that on the higher energy diet, intake's much better, and the differences in milk yield very much less.